Here's another quick application of nodal analysis. So they're asking us to use the nodal equation approach, and they want us to find the voltage across resistor R5. So that'd be the voltage across this resistor right here. So we note that there are two major nodes here. So we're going to go ahead and designate those as A and B. So let me do this in red. So this will be node A, this will be node B. And so then we'll have the voltage here is VA, the voltage here is VB. And we can use this then to determine what our voltages will be and to derive our equation. So let's do that real quick. So looking at this, we'll say VA is the blue node, or the A node is the blue node. And so as we start to go around this, we will see first we have this resistor here, R1, and we can write using Ohm's law, the current coming. Remember, when we do nodal analysis, we're just summing up the currents going in and out of a node. So the current coming out of that node then would be VA minus 10, which, V1 is 10, and that's divided by R1, which is 5. And so coming around, we see we have another resistor here. And to write that one, that's going to be plus VA, again, minus V2, which is also 10, and divided by R2, which is also 5. And then finally, we're going to see this R3, which we'll put in red. And so that's going to be VA, again, the difference in the voltages, minus VB across the resistor, and then over R3, which is 2. And so that should be all the current entering and leaving that node. So then, that being the case, we should be able to set this equal to 0. So next, we want to go over to node B, which we're designating here as green. And so let's start writing the current equations going in and out of there. So the first one is the red, so we'll go ahead and do that. So again, the difference in the voltage is VB minus VA, and that's over R3, which is 2. Okay, so then next, we're going to see this resistor here, and writing that one, that's just going to be VB over 2, because that one goes to ground, or to our reference node. And then finally, I've got it highlighted in yellow, but I want to do a different color here. Let's put this one in green, or R5. And so that one's going to be VB minus V3, which is 2 volts. And that's going to be over R5, which is 5. And so then that's all of the branches going in and out of that node. So then we should be able to set that also equal to 0. So now we should be able to do some reduction here. And so when we do, we can multiply through the top equation by 10. So let's do that. So multiplying by 10, and so then we'll get VA minus 10, or excuse me, it'll be 2 times VA minus 10 plus 2 times VA minus 10, and then that'll be plus 5 times VA minus VB. And that's all going to equal to 0. Same thing on the bottom, multiplying by 10. And here we'll get 5 times VB minus VA plus 5 times VB. plus 2 times VB minus 2. That will all equal to 0. And then we can multiply through. So if we do this one, it'll be 2VA minus 20 plus 2VA minus 20 plus 5VA minus 5VB. That's going to be equal to 0. And here we can multiply through everything. So it's going to be 5VB minus 5VA plus 5VB plus 2VB minus 4 equal to 0. So now finally, we should be able to take these and rewrite them, gathering all the like terms. So here we have 1, 2, 3, 4, 9 VA, and then we have minus 5 VB, and that's going to equal to, we've got negative 40, so it's going to equal to 40. And then on the bottom, we'll have minus 5 VA, again, just combining like terms, and we'll have 5, 10, 11, 12, so plus 12 VB, and then that is going to equal to 4. That's what we come up with there. And so then we can solve this. I mean, this would just be a simple array then. 9 minus 5 minus 5, 12. And then the VA, VB. And that'll equal to 40 and 4. Oops. And 4. So again, using whatever linear algebra method you prefer, you can solve for VA and VB doing this. And when we do, what we come up with then is that VB is equal to 2.84 volts. So that's VB. What we're asked to find is the voltage across R5. So when we look at our schematic, we see that the voltage across R5 is going to be the difference in VB and V3, this voltage here. So that's going to be equal to VB minus V3. That should give us our voltage. And so when we do, that'll be 2.84 minus 2. So when we subtract that out, we should get 0.84 volts. And so this is the answer they're looking for. That is the voltage across this resistor.